Excess limiting reactant problems, page 8, number 8. And this one looks like there's a lot of questions asked. So we'll probably do a complete icebox with this one. And here we go. We got 720 grams of sodium hydroxide is mixed with 980 grams of phosphoric acid. This is sodium hydroxide. And this is phosphoric acid, the H3PO4. Okay, and then a number of questions are asked. Because I'm asking so many questions, I'm going to fill in the box and then use that to answer the different pieces. So let's look here and let's balance our equation. Looks like I got 1 sodium and 3 sodiums, so I'm going to throw a 3 up here. And I'm going to put a 1 here. And I got 1 group of PO4. I'll put a 1 here. That's another group of PO4. It's a little bit confusing. Notice I got the PO4s cancel out, but I got 3 oxygens here. So I'm going to put a 3 here. Now, where does that leave the hydrogens? 3 times 2 is 6. 3 hydrogens here, plus 3 more hydrogens here, which adds up to 6. So I think this is balanced, 3, 1, 1, 3. All right, I have 720 grams of sodium hydroxide. What do? I convert grams to moles for sodium hydroxide. The molar mass of sodium hydroxide shown here is 40. So I'm going to take 720 and divide that by 40. So I got 720. And that's going to be over 40. And I believe that ends up being looking at the wrong thing here. And need to calculate that. Okay, I think that's going to be 18 moles. Okay, sorry about that. So I'm going to call this 18 or 18.0 moles. That's going to be of NaOH. Okay, I'm going to do the same thing with H3PO4. The molar mass is 98. I'm given 980 grams. I think I can do that math. I think that's going to be what? 980 over 98.0, and that's going to be 10 or 10.0 moles. Okay. And again, let's see, I think that looks pretty good. So I'm going to make an ice box for initial change in N. I'm going to draw that in. So put an I here. That stands for initial amount of moles. C is for change. And E is for at the end. And that's how we're going to use this right here. Okay, the initial amount of moles is what I'm starting with before any reaction occurs. And that is 18.0 for the NaOH. 18.0. And for the H3PO4, it is 10.0. Okay, for the products, we don't have any products before the reaction occurs, so that's going to be a 0, and this is going to be a 0 by the H2O. Next thing is we got to determine our limiting reactant. Okay, so a couple ways I could do this. I could look and say, oh, this is bigger, this is an excess. 18 is bigger than, not necessarily, because it's supposed to be 3 times as big, and it doesn't look like it's 3 times as big. So I think that 18 is going to be the limiting reactant. Let's do a double check. The other thing I can do is take 18 divided by 3. So I'm going to just take this and do 18.0 over 3, and that equals about 6. All right, and the other thing I can do is take, I can keep going here, and I'm going to take 10.0 over 1, and that equals 10. So what I did was I took this 18 divided by its coefficient, it gets to be 6. 10 divided by its coefficient 1 gets to be 10. So the smaller number here is the limiting reactant. So even though NaOH has more moles, it's not 3 times as many moles. So it's going to limit us from making more product. It's going to run out first. And then the H2SO4 would be in excess, or I'll just write excess right here. All right, so we've converted from grams to moles. Then you take the moles divided by the coefficient, moles divided by coefficient, the smaller one's the limiting reactant. All of your limiting reactant reacts. So this will be 18.0 here. And how do I fill this out? 18 times 1 over 3. I'm coming from the 3, that goes on the bottom, the 1 goes on the top. So it's going to be 6.0 or 6.00 if you want, right here. Put a little decimal there so you can see that. Notice 1 to 1 right here, so this stays at 6.0. And this stays at, 3 to 1 to 1 to 3. If this is a 3 and this is a 3, then this is an 18. This will be an 18 right here. So notice the numbers in the change parallel what's going on in the balanced equation. 3 times 6 is 18, 1 times 6 is 1 times 6, 3 times 6 is 18. So everything's 6 times bigger when I do the change. Technically, these are minuses here because you can either subtract them, and then these would be pluses because these are what's formed. These are reacting. No limiting reactant left over. My excess reactant looks like 10 and negative 6 is going to be 4.0. Okay. The H3PO4 achieved the 4.0 moles excess right here. And this is going to be 6.0 right here. I don't know if it's necessary to repeat that, but I will. And this is going to be 18.0 right here. And I'll write that my sloppy writing here. And we get this. Now we got a barrage of questions. So I had a lot of questions. I think I'm just going to complete this box and then answer things. Balance the equation. We did that. Check. Oh, I feel good writing that little check mark. What is the limiting reactant? We identified that as NaOH. This is perfectly fine. I think it's very obvious it's NaOH right here, but I'll just reinforce that and write NaOH right here. It is nice when you write these things down in the box so you interpret this out of the box. What is the excess reactant? It's the H3PO4. And you want to indicate this. So this is what I'm pulling out, pulling that down here. And I'm going to say it is what? How would I answer this? I'm going to say 4.0 moles excess H3PO4. No doubt for the reader that you know this is it and that you know it's not the 10 or not the 6. That's the excess. The actual excess is 4. That's what's left over. Okay, initial minus what reacted leaves you the leftovers. Now the last two questions, I can't really scroll up here and on that, so I didn't plan that. Well, one question was how many moles of water? Well, we could say this will be D. I'm just going to circle this right here and say D and write this in, maybe do a little arrow because you're given that in the next thing, but you can't see it. And I'm going to say 18.0 moles of, I'll say D. Letter D is 18.0 moles. And I think I can write H2O right there. Okay, we have that. So that was letter D. That's this little spot right here. All right, that's where I got that from. Okay, Okay, sorry, I'm kind of playing. And then the last one is, E says, what mass of sodium sulfate is produced? Okay, so we go here and let's change this, I think, to a different color so you don't have any mass confusion with this. This would be 6.0 moles, and it's going to be times 164 grams per mole. You can see right above, that's the molar mass. And I'm going to say grams per mole, and that's going to equal, I believe, 984 grams. 84 grams. And I will clarify that, Na3PO4. Now, if I were answering this problem, if you scroll down here, you'll see D and E, but I kind of didn't plan that out well, so you can see this. So this would be letter E right here, all my work for this right here. So I use this value of 6, but it asks for mass so that I converted it to grams. D asks for moles, so I just did that. It says what mass is left over. I didn't do that quite right. So I have to take 4 times what? 98 grams per mole up here. Grams per 1 mole. So that's where you do the double check at the end. It's like, I know my moles, I know my mass, and just double check to make sure you do things right. And I think that's going to be 392. And I'm going to say grams. And I could say, we know it's H3PO4, but I'll write it in here, H3PO4. And then we know this here. So let's double check everything. Balanced equation, limiting reactant, check. What react is in excess? It's the 4 moles, but it asks for mass. So I will get that right, 392. Question D asks for moles of H2O. So this was D. And then question E asks for mass of Na3PO4, which is this right here. Notice 6 moles times the molar mass of Na3PO4, which gives me this. This is a pretty long, tedious problem, especially the molar masses. I think if you're given the molar masses, it takes less time to do these, but this kind of has an everything problem. Notice the use of the icebox to kind of monitor and keep things in a reasonable amount of time and space. All right, hope that helps. Thanks for watching.